All right, here we go. So let's just scroll down real quick. Did anybody have any questions with like the first 10? Anybody want to say anything about the first 10? All right, now let's look at maybe the next 10. Anybody want to look at the next 10? Yes, which one?
Like 19.
Okay, here's 19. Look up there on the board. If a number is divisible by 4, then it is divisible by 2. If a number is divisible by 4, then it is divisible by 2. All right, is that true?
Wait, if it's divisible by 4, it's divisible by 2?
Yes,
Yeah, that's true.
that is definitely true. All right. The converse. If a number is divisible by 2, then it's divisible by 4, obviously is false. Right?
Mhm.
So the converse, they're trying to show you again, the converse doesn't have to be true. Sometimes it is, sometimes it isn't. The inverse, if a number is not divisible by 4, then it's not divisible by 2. False too, right?
Yeah.
You agree?
Why is it not? Yeah.
Well, what number is divisible by 2 and not divisible by 4?
Okay. Yeah.
Now, what did we say yesterday about the contrapositive? If the, go ahead.
Oh, if the conditional is true, then the contrapositive is true.
Yeah, so you don't have to worry about it. If you say the conditional is true, the contrapositive is true. All right? Yes.
If the conditional is false, then the contrapositive.
I don't think it has a, I never really thought about that. If the contrapositive is false, it seems like, if the conditional is false, the contrapositive seems like it would be false.
Okay.
All right. I can't say that because you're the first person who's asked me that. All right. If the I let's look that up. You know what I mean? I'll look that up and see. But I think that's probably true. If the conditional is false, the contrapositive would seem false. All right. That's a good question. All right. So now let's do the next problems. Go.
26.
All right, so everybody, let's look at 26 and see what that says. All right. So now the conditional must be true and the what? For a biconditional. What was it? The converse, right? The conditional and the converse are true. Then you can write it as an if and only if. All right. So a triangle is obtuse, or an obtuse triangle has one obtuse angle. So if you write the converse, it would say if a triangle has an obtuse angle, then it's an obtuse triangle. What?
What do you mean about if the conditional and the converse are true? How do you tell that they're both true?
You read what it says and see if it's true or not. So if a triangle is obtuse, then it has one obtuse angle. That would be the conditional. Is that true?
Yeah.
Now, if you wrote the converse would be if a triangle has an obtuse angle, then it is an obtuse triangle.
Okay.
Is that true? Then you can write it as an if and only if.
Okay.
Right? The triangle is obtuse if and only if it has one obtuse angle. Yes.
If it's false, you don't have to do it if and only if.
Yeah, I believe that's true. Yeah. Right. But I'm not sure. I didn't go through all these. I didn't know if any of them were false. Were any of them false?
Yeah.
The one before was? An integer is a rational number. If a number is an integer, then it is rational. That's true, right? Is the converse true? No, because 1/2 is a rational number and it's not an integer.
Mhm.
So you can't really write it as an if and only if. Or we're saying that they wrote it, but it's false. Right? What?
Oh, no, no. Oh, I have a question on number 22.
22. All right, let's look at 22. Unless you have something on this one.
No, I was just wondering what a rational number was.
Rational means a fraction.
Oh,
Any number that can be written as a fraction
oh,
is rational. You can be rational without being an integer. If you're an integer, then you're automatically rational because any number can be written over 1. Okay, so tell me about, you said 22,
yeah.
a number X. I don't know what we're doing here. What are the directions? A number X such that X is greater than negative 0.5 is positive. Oh, we're still writing if and only if, right? But that's what? That's false. True? You can give me a number greater than negative 0.5 and it's still negative, right? Elise?
Yeah, it's to do something like ask.
Okay, so yesterday we rushed at the end, so I totally understand. So biconditional can be written if the conditional is true and the converse is true.
Yeah, there's about a number X.
So they're just saying if you have a number X and it's greater than negative 0.5, it must be positive. And we know that's what? False, right? So the biconditional would not hold true, right? Because the conditional itself is not true. The conditional must be true and the converse must be true. Then automatically the biconditional is true and you can write it as if and only if. All right? Yeah. All right. What?
Could you have written it as a number X is positive if and only if X is greater than negative 0.5?
What? Say that again.
A number X is positive if and only if X is greater than negative 0.5.
Yes, right. That would be the converse, right? Is that what you're asking me?
No, I'm asking if that would cut off.
No. The first statement goes first. The second statement goes second, right? I thought you were asking me about the converse. The converse is what you want to check the converse to see if it's true, right?
Mhm.
All right.
I'm so confused when we put if and only if.
Um,
Like some of them don't make sense if we put it in there.
which one doesn't make sense?
Um,
Like for me on the test, I'm going to say, if you can write as an if and only if statement, write as an if and only if.
okay.
So you'll have to know that the converse has to be true also with the conditional.
Okay.
You with me on that?
Yeah.
So this one, I would say, no, you can't write it as a biconditional because the biconditional is what? False, right? The converse is not true. Agreed? All right. And again, we're not going to do a whole lot with this. All right. So this is just information, right? That's kind of helping you hopefully later, if you wanted to take some logic class, this is supposed to be helpful.
Okay.
All right. What?
Can you do 29?
All right. So let's look at 29. You good?
Mhm.
All right. Somebody else before we get started. All right. So I think it's important for me to go ahead and collect these guys. All right. Let's go. And then we'll get started with section 2.3. If you want to open up your book, that's fine. I'm just going to come around and collect this real quick. So let's go. Here we go. Then we get something called the Law of Detachment, and we get what's called the Law of Syllogisms. Yeah, I'm gonna give it back to you real quick. Hopefully by the end of the class, I'm just gonna double check what you guys have done. So good work so far. Now what we want to do is let's take a look. Now, really, I'm just gonna, I thought this would be easier for me for 2-3. I went ahead and kind of printed out. Well, I didn't really print it out, but what I did was I put it on mine. All right. And so we're just gonna just walk you through it. All right, to start out. All right. The thing I would like for you to write down is just the two things that the two laws that I'm going to try to show you. All right. I think personally, for the first time, these two laws make really good sense, and they can actually help you understand, you know, how something is true or how something is false. All right. So I kind of liked today's lesson. It does make sense to me. All right. And I'm going to show you how when you take higher level math, they're going to start writing things. All right. And it looks a little weird, but everything has been abbreviated. All right. So first and foremost, there is something called inductive reasoning and something called deductive reasoning. Inductive reasoning is kind of what we're doing in geometry. We're just making some observations. All right. We're making some observations, and then we're branching out from those observations and trying to prove things. And that's kind of what settled me down when my geometry teacher told me point, lines, and planes were undefined. And then yet everything else is based off of those. All right. So again, that would be inductive reasoning. And today it's what? Deductive reasoning. And deductive reasoning is when we are creating the rules, and you have to what? Follow the rules to draw the conclusions. And that's kind of what we were talking about yesterday when I didn't like the fact that, what was our statement yesterday that was absurd? Yeah, if pigs fly, then bees are lizards. All right, to me, that was meaningless nonsense. And I had someone actually, Catherine did, I thought, a good job, all right, trying to explaining it. And so I'm going to read kind of what she said. It says a conditional statement is true by virtue of the fact that its hypothesis is false. There really is no explanation for this, and it remains true by default. This is also called a vacuous truth in math, which is simply just a universal statement which will always be true because the narrative cannot be satisfied. All right. So again, I'm still not satisfied with that. But again, it's someone doing the research telling me that it's just something that someone made up and said that it was true. All right. Because to me, it seems like if I was making things up, it's obviously pigs can't fly. So, right. So it seems like it would be not true. All right. But again, there's an explanation here about a vacuous truth. So hopefully you now understand a little bit about what I'm trying to say is that's just something we have to accept. It's not easy for me to accept things in math. I want to know why. I want to be able to show you why. I don't like when I have to say, just here's the reason, accept it as true. And that's what's difficult about me teaching geometry. There's things you just have to accept as true. Okay. Now today, the law of detachment and the law of syllogism is not something you have to accept as true. I think it's somewhat logical. All right. So with that being said, all right, we're going to talk about the law of detachment. All right. If somebody tells you or gives you a conditional statement, and that conditional statement can be written this, what does that say? What, go ahead, tell me. What does this say right off the bat? Tell me.
If P, then Q.
Right. That's all it says. It's our conditional. It's the abbreviation. It's the algebra for sentences. If P is true, then Q is true. Now that's a conditional, right? If P is true, then Q must be true. Now, if someone comes along and says P is true, all right. If P is true, I'm going to move it down. Then what can you conclude?
Q is true.
Q must be true. And then we write this, and later on in college, hopefully, for those of you guys who study, you'll learn all these symbols. All right. The first one is if P, then Q. And then actually, sorry, I should have written P further to the right because it's like this. If P, then Q, P, therefore what? Q. That's literally what that says. All right. If P is true, then Q is true. P is true, therefore what? Q must be true. Now it has to be in that order. So if somebody says to you, if P, then Q, and Q is definitely true, therefore what? Therefore what?
Q is true.
There is no valid conclusion. Why is there no valid conclusion? Right? Just because Q is true doesn't make P necessarily true. Does everybody agree with that? All right. It has to be exactly in that format or you can't make a conclusion, which to me was logical. Why was it logical? Because we said if X equals 2, then X squared equals 4. If X equals 2, therefore what? X squared has to equal 4. So I agree with that. All right. So again, it has to be in that exact order in order for the conclusion to hold true. This must be true. All right. If I said X equals, or if I said down here, X squared equals 4, if I said X squared equals 4, then can I conclude X equals 2? No, that's not true because X could have been what? -2. So hopefully you understand what I'm saying. It has to be PQP, therefore Q. All right, so I think I've done a good job explaining that. We'll find out right now. All right, determine whether the statement or the stated conclusion is valid based on the given information. What?
Where'd you find this?
I printed it out for myself so I could explain it.
Okay.
It's primarily, honestly, it's primarily because I just want you listening, truthfully, right? I know I could easily give it to you, but again, I just want you to listen. All right, I think that's important. You with me? All right, and if some of you would like me to send this to you, I don't mind doing that, but I just want you to show, I'm trying to show you it's really kind of easy. All right, and if you want to write some notes on there on your paper, I'm totally good with that, but it's unnecessary. All right, and what I'm trying to show you right now is if we can do 1, 2, and 3, then you understand the concept. Yes. Can I do what?
Explain what deductive is.
So, yes. So this is called deductive reasoning. The reason why it's called deductive reasoning is because I'm giving you rules. You follow the rules, then you can make the conclusions. You with me? Inductive reasoning is just based off observation. Okay. Every day it's rained for the last week, so tomorrow it's going to rain. That's just inductive reasoning. You with me on that? There's no way for me to prove that tomorrow's going to rain, right? I just think it's going to rain because it's rained every day. You with me? All right. So deductive reasoning is I'm going to tell you rules and laws, and you're going to follow those rules to make the outcome. All right. Just like we're doing for these problems right here for number 1. If a number is divisible by 6, then the number is divisible by 3. So I used to put on my, and again, honestly, I tell kids all the time, I didn't do this in geometry, I did this in college. All right. So that's why I'm a little, I really don't like this section. But I've seen it come up now on SATs and ACTs every once in a while, just basic stuff. So if you know the basics, you'll be good. So what I like to do is, if a number is divisible by 6, that's the letter what? If a number is divisible by 6, what letter is that? P. Thank you very much. Thank you for participating. Then the number is divisible by 3. What is that? Q. We're not on a page, we're just writing it down. All right, if you want, or you can just really concentrate and listen. All right, I don't care about writing it down. Some of you are okay with writing notes. All right, if you don't want to, you're just really concentrating. I'm really happy with that. So now we would write what? If P, then Q. All right. Now, what I want to highlight now is 18 is divisible by 6. What is that? What letter is that?
P.
That is P. All right. Therefore, what is true?
Q.
Therefore, Q is true. Now, if we were going to say Q, we would say what? 18 is divisible by 3. You okay with that? What?
How do you figure out if Q is true by doing that?
Okay, because listen, you have to accept the conditional statement is true. Can you tell me if a number is divisible by 6, then it's divisible by 3? You sure? That's true, right? Now, again, to me, I like this because I think I can understand that, right? Every number that is divisible by 6 is also divisible by 3. We can prove that if you want, but it's unnecessary. We just know that's true, correct? So we now have concluded that the conditional is true. So if the conditional is true, and now I tell you that P is true, then what has to be true? Q has to be true. You with me? All right. And again, I'm going to do it on number 2, and we're going to do it on number 3. All right. So I appreciate, just listen hard. All right. I'm not saying it's easy. I'm saying it's easy after you understand it. Right. That's all I'm saying. So now let's look at 2. If a pet is a rabbit, so what is P? A pet is a rabbit is what? P. All right. This is how I did it on my college papers. All right. You just identify and you write the letters. So this is P. Then what? Then it eats carrots. Eats carrots is what? Q. All right. So now I come down and write if P, then Q. So now it says this person, pet, eats carrots. So what is that? You have to decide, is it P or Q? Right? You can't do the problems if you can't put it in the right letter, right? That's why I like the letters, so I'm not confused. It's easy for me to understand the law of detachment, right? If P, then Q. P must be true, automatically Q is true. If it's not in that order, then it's what? Then it's false. All right. So Jeannie's pets eats carrots. So eating carrots has to do with what letter? Q. Therefore, what? There is no valid conclusion. All right. And again, now I'm getting to a point where I just say, after 2 examples, I feel like you should be pretty good at that. Right. That's it. It's nothing more difficult than that, honestly. The law of detachment. I don't even know how they come up with that word, law of detachment. All right. But that's what they decided to call it. All right. So let's try one more just to make sure before I show you the law of syllogisms. All right. So here we go. If a hen is a Plymouth Rock, what is that? P. Then what? Her eggs are brown. Q. So if P, then Q. Berta is a Plymouth Rock hen. P. Therefore, Q is true. Therefore, her eggs are brown. Simple. Really simple. All right. Let's not make it more complicated than that. That's all there is to it. Everybody good? All right. So now more deductive reasoning. All right. The law of syllogisms. Another way to make a valid conclusion is to use the law of syllogisms. It allows you to draw conclusions from two statements when the conclusions of one statement is the hypothesis of another. Blah, 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 right? I understand that. So watch how simple this is. If P, then Q is true, and Q, then R is true, then automatically what? Yes. All right. So how do we write this? If P, then Q, Q, then R, therefore P, R. Everybody good? And guess what? Does the order matter? Yeah, it does matter. All right. So again, I just wrote this down for myself. All right. And I followed this exact order. All right. And it seemed like it worked out for me. So here we go. So here, let's just practice. If a number is a whole number, then the number is an integer. So if a number is a whole number is what? P, then the number is an integer is Q. The number is an integer, Q, then it is a rational number, R. Notice some statements are the same and some are different. If the statement is different, it's a different letter. Does everybody agree with that? So now you look here, the number is an integer, the number is an integer. Those are the same. So we use the same letter. Right? So because we said P, then if P, then Q, and then we said Q, then R, therefore we know what? Right. We know a number is a whole number. If a number is a whole number, then it is a what? And to me, that makes perfectly good sense if I just think about it. If a number is a whole number, then it is an integer. If it's an integer, it's rational, right? And we did that, believe it or not, in 7th grade last year when we did the, naming of all the numbers. All right, so now let's come down here and see. If a dog eats super dog food, he will be happy. So a dog eats super dog food is what? P. He will be happy. Q. Rover is happy. Right. Now, to me, this sounds like it would be more of the law of detachment, right? Right. So is that true? Can we make a statement here?
No.
I would say no valid conclusion. All right, now, don't be shy. I don't mind. All right, no valid conclusion. If P, then Q, Rover is happy. Q, therefore, no valid conclusion. Because this Q is supposed to be a what? That Q is supposed to be a P, right? if we're going to use the law of detachment. Okay, so here we go. Help me. If an angle is supplementary to an obtuse angle, then it is acute. If an angle is acute, then its measure is less than 90. Simple. So you can write P to Q, Q to R. Therefore, we can conclude what? P to what? R. So then I would just go back and write it. If an angle is supplementary to an obtuse angle, then its measure is less than 90 degrees. I just think that's kind of easy. All right, once I realized that, I just said, let's move on. All right, so let's go to the next one. If the measure of A is less than 90, P, then angle A is acute. If angle A is acute, then the measure of angle A is congruent to measure of angle B. R. What are you thinking? So you see that? P to Q, Q to R. Therefore what? If the measure of angle A is less than 90, then angle A is acute. If angle A is acute, then angle A is congruent to angle B. All right, that's what they're saying. So does that follow the rule? So we can conclude what? We can conclude P to R. So we could conclude if the measure of angle A is less than 90, then angle A is equal to, or is congruent to angle B. All right, now let's look at number 4. If an angle is a right angle, what's that? P. Then the measure of the angle is 90. If two lines are perpendicular, R, then they form a right angle. Is that valid? No, it's not valid because it's not P to Q and Q to R. What? Because it doesn't follow this format. It has to follow that format. We have P to what? Q, then we have what? R to P. Do you agree with that now? Okay. All right. The end. All right. So now we have kind of some homework. All right. If you want to head your paper up, that's what I'm looking at. Pages 135 through 138, numbers 1 through 36. If you want to take a look at that. I'm probably going to change it. All right. I'm going to probably change it, but I also put in there, I also posted the solutions. I know I did this time. All right, so let's go ahead and just get started. And then in 5 minutes, I'll evaluate how much homework we have. All right, I don't want you to have too much. All right, so here we go. So now, all right, if you want, let's look up there. It says, students at Olivia's high school must have a B average in order to participate in sports. Olivia has a B average, so she concludes that she can participate in sports. All right. So determine whether each conclusion is based on inductive or deductive. What are we thinking here, guys? Deductive, right? Because we're just following rules. And this would be the law of what? Yeah, detachment. The law of detachment. By the way, is that true? Yes. Yes. Deductive is just following the rules. Or inductive is kind of what we're doing, just things based off observation. All right. So like at the beginning, when we talked about points, lines, and planes, those things that I gave you at the beginning so far, that was all what? Inductive. Because we're not using rules, we're just saying this is true. Right? Does that make sense? All right. So it's based off observation. Okay, yes.
Can you just write deductive?
Yeah, I'm good with that. I'm good with writing deductive. Okay, here's what I'm saying. Now, this will help you hopefully understand the difference, right? So Holly notices that every Saturday her neighbor mows his lawn. Today is Saturday. Holly concludes her neighbor will mow her lawn. Now to me, I think we could go either way here. Do you agree? Because we could put it in if P then Q, right? But in this case, it's, an observation. Holly notices that every Saturday, her neighbor mows her lawn. Today is Saturday. So does everybody understand what I'm saying? It's kind of a little iffy, right? I would probably say, honestly, this is inductive reasoning. Right? Why would I say it's inductive reasoning? Because she's making an observation, right? She's observing that the neighbor is mowing the lawn every Saturday. If today is Saturday, then the neighbor's going to mow the lawn. Okay, but I don't think there's a rule that her neighbor has to mow the lawn on Saturday. Correct? All right, that's why some of these questions are a little sketchy in my opinion. I would put inductive and then, all right, let me, well, you guys have the solutions. You can double check me to see if I'm right later, or you can look it up now if you want, but let's just keep going. Determine whether the stated conclusion is valid based on the given information. If not right, invalid. All right, so here's what I like. I think we kind of did this one, right? If a number is divisible by 4, then the number is divisible by 2, right? So we have P, then Q. 12 is divisible by 4, so that's what? P, therefore Q. So is this valid? Valid.
We just write valid.
All right, so let's look at 4. If Ellen stays up late, that's P, he will be tired the next day, Q. And then Ellen is tired, that's what? Q. So, right, a lot of people think that's necessarily valid. No. Because it's if P, then Q, therefore not valid. All right, not valid. All right, here we go. Determine whether the stated conclusion is valid based on the given information. If a beach is public, that's what? Then it does not have a lifeguard. Bayview does not have a lifeguard. What? Yes. Invalid. All right, I'm totally good with that. Yes. No, just write down the answer. I'm totally fine with that. But because I'm more important is I feel like we understand it. Right? You don't have to write out though. I don't want to write all that. All right. I'm not interested in spending extra time. Okay. So we're just writing valid or invalid. I think it's important for you to write down PQ so you can see everything. All right. Because I think that's how you determine easily if something's valid or not. So number 6. If a student passes the entrance exam, that will be what? They will be accepted to college. Letitia passed the entrance exam. P. So valid. Right? That's easy. Okay. If a triangle is a right triangle, then it has an acute angle that measures 90 degrees. Oh, I'm sorry, I read acute. Then it has an angle that measures 90 degrees. If a triangle has an angle that measures 90 degrees, then its acute angles are complementary. So number 7. if the acute angles of a triangle are complementary, then it is a right triangle. So here we go. If a triangle is a right triangle is what? Then it has angles that measure 90 is what? If a triangle has an angle that measures 90, then its acute angles are complementary. R. If the acute angles of a triangle are complementary, then it's a right angle. Or then it's a right triangle. Then what is that? P. Is that out of order? Yeah, so I say it's not valid. All right, let's look at 8. If a triangle is a right triangle, then it's the two acute angles are complementary. So again, if a triangle is a right triangle, what's that? P, then its acute angles are complementary. What is that? Valid, right? Now it says if a triangle has an angle that measures 90 degrees, what is that? Q, thank you. Then its acute angles are complementary. So again, we can say what? Is that valid? How is that? Because we said P to Q, and then we said Q to R, right? I'm pretty sure that's not the right order, correct? I know that's weird because why? Because is this statement true? But yeah, it's not in the right order, right? Tell me. You have to list out the P, Q, and R, right? Do you understand the P, Q, R? How we wrote P up here, Q, Q, R, right? So to me, it has to be in that order, right? And number 8's the one that has it in the correct order. Therefore, P to R is true. You with me? All right, so listen, guys, I'm okay with you doing the odds. All right. Just do the odds. All right. Oh, hey, Lucas, I'm sorry I didn't see you there, buddy.
Hello.
All right, have a great day, Lucas.
You too.
All right, bye. Let me know when you come on next time. Golly.